In section 8.6, we're going to talk about solving equations that have roots in them. And let's start by looking at the equation the square root of x equals 3. Solving an equation means finding a value for the variable that makes the equation true. So we want to think, what could we put in for x that would make this equation true? And if you think about it, many of you may know that the number whose square root is 3 is 9. So x equals 9 would be the solution to that equation. Now, sometimes you'll be able to just look at it and figure out the answer. For many of the problems in this section, you're not going to be able to just look at it and figure out the answer right away. We're going to have to do some work. And to do that, we need to know how to undo the square root. And to undo or cancel out a square root, you want to square both sides of an equation. Just like to undo subtracting, you add the same number to both sides. To undo multiplying, you divide both sides by the same number. When you have a square root that you want to get rid of on one side, you square both sides. So for example, if we have the equation the square root of y equals 12, we put parentheses around both sides and square both sides. On the left side, the square root of y squared. Remember what we said in a previous section, that when you multiply a square root by itself, you just get what was under the root? So the square root of y times the square root of y is just y. And on the right side, 12 squared is 144, like that. Or if we take a look at our next one, the square root of w equals 7. We put parentheses around both sides and square both sides. On the left side, the square root of w times the square root of w is w. On the right side, 7 times 7 is 49. So we get w equals 49 for the answer. Let's take a look, though, at what happens when we try to do that with our next equation, where we start with the square root of x equals negative 10. If we put parentheses around both sides and square both sides here, the square root of x times the square root of x is just x. On the right side, negative 10 times negative 10 is a positive 100. But we need to check that. That's actually not a solution to this equation. If we check that by plugging it back into the original equation up there, we would get the square root, instead of x, we would have the square root of 100 equals negative 10, but that's false. The radical sign, when it's written that way, the square root of 100 would be a positive 10, not a negative 10. So that means x equals 100 is not a solution to that equation. So here's something that's very important to understand in algebra. When you square both sides of an equation to get rid of a square root, sometimes you end up with a false answer. Just like we sometimes had false answers that made the bottom of a fraction 0 in the previous chapter, in this chapter, when you square both sides or raise both sides to any even power, you sometimes get false answers. So that said, let's take a look at an example of how we're going to solve these equations. Our next one, we have the square root of 3x minus 2 equals 5. So to get rid of that square root sign, we put parentheses around both sides and square both sides. On the left side, squaring cancels out the square root sign. So the square root of 3x minus 2 times the square root of 3x minus 2, we just get what's under the root, 3x minus 2. On the right side, we have 5 times 5, which is 25. And now that the root's gone, it's just a regular algebra equation. You would add 2 to both sides, and we get 3x equals 27. To finish, you divide both sides by 3, and we end up with x equals 9. So in general, here's the steps you're going to go through to solve all the equations in this section. Step 1 is get the root by itself on one side of the equation. Just like factoring, you have to move everything to one side and get it equal to 0. Here, you want the radical by itself on one side and everything else on the other side. Step 2 is raise both sides to a power equal to the index of the radical. That sounds very fancy. All it means is to get rid of a square root, you square both sides. To get rid of a cube root, raise both sides to the third. To get rid of a fourth root, raise both sides to the fourth. To get rid of a fifth root, raise both sides to the fifth, and so on. Then you solve the equation and check your answers. So that said, let's take a look at our next problem. Here we have the square root of 8x plus 20 minus x equals 0. So step one, before you think about getting rid of the root, you have to get the root by itself. Here we accomplish that by adding x to both sides. On the left side, that leaves us with the square root. The square root of 8x plus 20 equals, and on the right side, we would just have x. Now we can get rid of the square root by putting parentheses around both sides and squaring both sides. On the left side, the square and square root cancel each other out, and we just get 8x plus 20. On the right side, x times x would be x squared. So if you square both sides and you end up with one of these equations that has an x squared in it, let's move everything to that side where the x squared is so we can try to factor it. So we're going to subtract 8x from both sides, and we're going to subtract 20 from both sides. And when we do that, we would have 0 equals x squared minus 8x minus 20. Now that we've got everything on one side and 0 on the other side, we can factor it. It starts with x squared, so we can just put x at the beginning of each group. Then to multiply to be negative 20, but add up to negative 8, you would have minus 10 and plus 2. Now we set each one of those factors equal to 0. X minus 10 equals 0, then I'm going to leave some space. X plus 2 equals 0. The first one, you just add 10 to both sides, and we have x equals 10. The next one, you subtract 2 from both sides, and we have x equals negative 2. So right now, it looks like there's two answers to that equation. But it's very important, because we squared both sides, back up in that earlier step, we need to check our answers. What we're going to do, for example, to check x equals 10, we're going to go back to the original equation, and everywhere there's an x, we're going to replace it with 10 and see if it turns out to be true. When we do that here, instead of the square root of 8x plus 8x plus 20, we have the square root of 8 times 10 plus 20. Instead of minus x, we have minus 10, and then equals 0. And we want to see if this is true or not. Well, 8 times 10 plus 20 is 100. The square root of 100 is 10. So we have 10 minus 10 equals 0, and that works just fine. So when we checked that number, we got a true equation. X equals 10 is a solution. Now let's try checking negative 2 the same way. When we replace x with negative 2, we have the square root of 8 times negative 2 plus 20. And then notice we're replacing the x, not the negative sign, but just the x with negative 2. So minus negative 2 equals 0. 8 times negative 2 plus 20 is 4. So we get the square root of 4, and then minus negative 2 would be plus 2 equals 0. Here we get 2 plus 2 equals 0. That's false. So x equals negative 2. It was an answer to the algebra steps, but when we check it in the original equation, that's one of those false solutions I was talking about. So it's a good habit on problems like this. Circle something that you've checked and is a solution. Cross something out that you checked that turned out to not actually be a solution to the equation. Let's try another example. Here we have the cube root of x minus 5 plus 2 equals 1. So we start by getting the root by itself by getting rid of the plus 2. To do that, we subtract 2 from both sides. And that leaves us with the cube root of x minus 5 equals negative 1. Next, now that we've got the root by itself, we put parentheses around both sides and we get rid of the root. Notice this time it's a cube root we're trying to get rid of. So instead of raising both sides to the 2, to get rid of a cube root, you raise both sides to the 3. Now on the left side, the cube root and the 3 exponent cancel each other out, and we just have what was under the root, x minus 5. On the right side, negative 1 times negative 1 times negative 1 is negative 1. And then to finish, you add 5 to both sides, and you end up with x is equal to 4. Now, when you raise both sides to an odd power, you don't create false answers. So as long as you've done your steps correctly, we don't necessarily have to check this one like we did the previous one. Anytime you raise both sides to an even power, you might be creating false answers, so those you really do have to check. Let's try another one. Here we've got the square root of 4 minus x equals x minus 2. So one good thing, the root's already by itself, so we don't have to move things around too much. Next, to get rid of the root, we put parentheses around both sides, and we square both sides. On the left side, the square root and the square cancel each other out. I'm going to leave a little bit of space, and then we have 4 minus x. The right side of this is where a lot of people make their mistakes in this section. When you have a parentheses with a plus or minus in the middle of it and it's squared, you don't just square both parts. You have to remember what it means to square something. Squaring something means multiplying it by itself. So here we're going to have x minus 2 times x minus 2, and we can use the FOIL method now to work through it. So the first terms, x times x, would be x squared. The outside terms, x times negative 2 is minus 2x. The inside terms, negative 2 times x is minus 2x. And then the last terms, negative 2 times negative 2 is a plus 4. And now to keep going, we want to solve it, so we need to get 0 on one side. Let's move everything to the right side, where the x squared is. So on the left side, to get rid of that 4, we subtract 4 from both sides. To get rid of the minus x, we add x to both sides. So doing that, on the left side, everything cancels out, so we get 0. On the right side, x squared doesn't have any like terms. For the x's, we have negative 2x minus 2x plus 1x. That ends up being a minus 3x. And the plus 4 and minus 4, because they're opposites, cancel out. Now here, you have to remember what you should always try to do first when you're factoring, which is factor out the greatest common factor. In this case, both of those terms are divisible by x. And when we see what's left, x squared divided by x is x, minus 3x divided by x is minus 3. And now we finish by setting those factors equal to 0. We have x equals 0, x minus 3 equals 0. The first one's already solved. The second one, we add 3 to both sides and have x equals 3. But remember, because we squared both sides up in that very first step, we have to check our answers to see if one or even both of these ends up being a false answer. When we check x equals 0, we're going to look back at the original equation that we started with, and everywhere there's an x, we put a 0. So instead of the square root of 4 minus x, it's the square root of 4 minus 0. On the right side, instead of x minus 2, we put 0 minus 2. Now when we simplify this, we get the square root of 4 equals negative 2, but that's false. The radical square root of 4, when written that way, should be a positive 2. So here, x equals 0 is a false answer. Now let's check the 3. Everywhere there's a 3 in the original equation, we put an x. So we would have the square root of 4 minus 3 equals 3 minus 2. This would give us the square root of 1 equals 1, and that's true. So we checked it in the original equation and got something true. That means x equals 3 is a solution to that equation. So let's put a lot of these steps together and take a look at one more example here. Here we have 3 minus the square root of 2x minus 3 equals x. All right, so the first thing we need to try to do before we square both sides is get the square root by itself. Here, to do that, our first step is to get rid of that 3 by subtracting 3 from both sides, leaving us with negative square root of 2x minus 3 equals x minus 3. Now, when you just have a negative sign in front of a square root, you actually don't need to do any algebra to get rid of it because of this little trick here. You put parentheses all the way around both sides and you square both sides. The trick on this one is squaring gets rid of the root sign and the negative sign. Remember, if you have a negative number squared, like negative 4 times negative 4, it'd be positive 16. Negative 6 times negative 6 would be positive 36. When you square something negative, it gets rid of the negative. So on the left side, squaring gets rid of both the negative and the square root sign, and we're left with 2x minus 3. On the right side, x minus 3 squared, we would have x minus 3 times x minus 3, and we use the FOIL method. The first terms, x times x, is x squared. The outside terms, x times negative 3 is minus 3x. The inside terms, negative 3 times x is minus 3x. And the last terms, negative 3 times negative 3 is plus 9. Now we keep going. We need to get everything on that side where the x squared is. So to move the 2x over, we subtract 2x from both sides. To move the 3 over, we add 3 to both sides. And this gives us 0 equals x squared doesn't have any like terms. Negative 3x minus 2x is minus 8x. 9 plus 3 is plus 12. Now we factor it. Whoa, it's a little big there. And to multiply to be a positive 12, but add up to a negative 8, we'd need a minus 2 and a minus 6. So we set both of those factors equal to 0. The first one you add 2 to both sides and have x equals 2. The next one you add 6 to both sides and have x equals 6. Now remember, because we did this step of squaring both sides, we have to check to see if one or both of these is a false answer. So first we're going to put a 2 into the original equation for x. So we have 3 minus square root, and then instead of 2x minus 3, we have 2 times 2 minus 3 equals, and then the right side is just x. So here we put 2. So let's do some simplifying here. That would be 3 minus square root. 2 times 2 minus 3 is 1. And this gives us 3 minus 1 equals 2. That's true. So x equals 2 is a correct answer there. Now let's take a look at the next one. We plug in a 6 for x. We would have, whoops, let me switch back there. We have 3 minus square root 2 times 6 minus 3 equals 6. Well, 2 times 6 minus 3 is 9. So if 3 minus the square root of 9 equals 6, well, that would be 3 minus 3 equals 6, which is definitely false. 3 minus 3 is, of course, 0. So that means that x equals 6. It was correct for the algebra, but wrong for the original equation. It's a false answer. So only x equals 2 is the correct answer there. The examples that we had always ended up with one true and one false answer, but you do sometimes end up with both answers true or both answers false. So you do need to go through that checking step for each answer to see if they're true or false.